Hello and welcome to this episode of Microchips, and on the bench today we have this radio that's been sent in to me, a Midland 79892, a vintage radio from 1977 with just AM and SSB, and it's been sent with a fault with no transmit, no receive. So let's see if we can get this classic back working again. But before we start, don't forget to like, share, subscribe, comment, join Patreon, join Facebook, buy me a coffee and all that. Have a look at my website, microchips.net. Let's get started. So this radio has a party trick. So you can see the microphone's a nice big chunky microphone. And on the back of it, it has a battery cover but no battery terminals. And a control on the top. And this control is the clarifier, because you may have noticed on the front of the radio there was no clarifier. So definitely a bizarre radio. And there's the serial number plate from the rear, April 1977, so definitely vintage, and a label on the bottom saying it's factory reconditioned. So I wonder if we can see where it's been reconditioned or repaired in the factory or whatever they did to it. So lifting the lid off, we have a beautiful 048 board, nice and simple, one of the best boards Cybernet made. The SSB on these sounds beautiful, and there's a PLL there from 45th week of 1981. And obviously they couldn't have fitted a 1981 PLL in a 1977 radio on manufacturer, so maybe that was the thing. So just having a look round, immediately my eyes were drawn to this burnt resistor in the output stage, and it's definitely that's definitely let the magic smoke loose and melted a little bit of the shrink wrap on the inductor. So we will check those and we will be replacing it, but we're going to have to check the output stage, make sure that's all working. So let's have a look at the circuit board side, see whether there's any horrors in there, because you know we do like cut tracks and stuff. So taking the lid off, we can see that the two metal cans that are supposed to be there are still there. Looks like it's had some work around the PLL and the VCO, so maybe that's what was done in the factory. When it was refurbed, maybe the VCO was repaired or replaced and the PLL was replaced. But having a good look around, there's absolutely no horror stories in this radio. So let's get to fault finding. So we're on the VCO test point, 5.3, 5.4 volts. That says to me that the VCO is absolutely unlocked. So let's have a look at the 10240. So the 10240 is definitely oscillating. It does not have the tantalum capacitor problem like the multi-mode 2s, as it has a ceramic disc in this one. But you can see 10240, no problem. And now we're having a look at the main mixer crystal. So this is the output of the doubler, and you can see 20 megahertz, which should be on TP3 or TP4 of the first mixer, so that's fine. So what do we change first? Well, I think we change the VCO first, because they are known to cause a lot of trouble. So we have one of my VCOs, and we're going to put that in, and we're going to see whether that makes any difference. So there's the old ZZ017 VCO. I'm not sure whether that looks right or not, but that definitely looks crusty on the inside. Almost like moisture's got in there or something. There's our nice new VCO. We're back on the VCO test point. Let's see what happens. So immediately we're greeted with 4.5 volts, which is not 5.4, which means the VCO is now locked. And changing the channels changes the VCO voltage. So that means that that's now working. So we'll test it on transmit. And we do have some transmit, but we've got just over a watt on the transmit. Could this be to do with the burnt resistor? Have we got a failed output? So as you can see there, 1 watt. And nothing on sideband, which is bizarre, so I'm going to have to check that out. So I'm just doing a continuity check across the final output, and it helps if you put it into diode mode. So base to collector doesn't look very good. It's reading very, very strange indeed. But that could be because of other components in the circuit. So we'll have to lift it out and check. So I've lifted the base and the collector. And sure enough, we're getting the same reading. The 1969's gone. Now, did the 1969 go and take that resistor out? Probably. Why? Who knows? Probably high SWR. But that transistor is definitely not reading as a transistor anymore. So we'll check the 2166 pre-driver. And we've got a strange reading base to emitter, but that may be a coil. But what we'll do is we'll lift that out as well and test it just to be sure. So I've lifted the legs of the 2166. That's a perfectly good junction, and that's a perfectly good junction. So this transistor is still a transistor. Just going reverse polarity, checking for any leakage, and that's fine. So the pre-drive has survived. Just the final output has gone. And there's the, well, it used to be a 10 ohm resistor. Now it's just a burnt. Yeah. So we'll check the coil that was next to it. Yep, that's fine. The coil's not open circuit. So we need to replace the transistor. So here's a transistor, still on its heatsink. So we'll do base. There it is. It's absolutely knackered. That's not reading as a transistor anymore. And the base emitter junction is open. So what I've done is I've fitted a nice new old stock transistor, and we're just checking the insulation between the tab on the transistor and the heatsink, because we don't want that to be shorted out and destroy our lovely new transistor. I've also fitted a metal screw and a proper insulation bush as well, because those plastic screws like to break, as we saw in my Concord 1 video. Before we fit it, we'll just check the bias voltage. I've just brought it down from over 0.7 to around about 0.7, and all this has got no load on it, but I just wanted to check the bias anyway, make sure it was not at any stupid voltage that could see off the transistor. So we've fitted a 15 ohm in place of the 10 ohm, so then we can set the bias voltage to 0.7 of a volt. And when we finally solder this transistor in, just like so, and there's our bias voltage, so 0.67, not too far out, but we'll just get the screwdriver in and we will adjust it to 0.7 of a volt. So keying up on sideband, there we go, 0.7 of a volt, lovely. And now we have a healthy output. Fantastic, we're getting there. There's still nothing on sideband, so it's almost like there's no mic input or audio. There's absolutely nothing, just a carrier on AM and nothing on SSB. So we have another fault. So I've got my frequency generator onto the input of the microphone, and as you can hear, we have transmit, we have audio, so there's something wrong in the microphone. So it gives us a chance to have a look in this microphone. As you can see, the clarifier control at the top, and there's no power amplification in this microphone, it's just standard. So I'm just transmitting and touching the microphone with a screwdriver and I can hear a buzz, so that proves that the cable's fine. So do we have a open circuit insert? Sure enough, the mic element is open circuit. Absolutely open. That would be why we've got no sound or no audio. So that's something else we're going to have to fix. Well, whilst we've got it open, we're going to clean the front of that microphone because it was absolutely crusty. And if you look back at the start of the video, you can actually see what looks like metal filings sticking up from the magnet. So using a nice paintbrush and a bit of foam cleaner, get nicely down into the microphone and give it a clean. Be a bit easier than doing it whilst it's assembled. Very nice. So we fitted another insert out of a standard microphone. I managed to find one that just about fit with a little bit of modification. Now we're going to do some extra work on this PLL side, seeing it's only mid-band. It would benefit from high band to make this usable on a 555. So to do that, we need to lift out the PLL chip. And there's our PLL, 8145. And there's my 5kc mod board that still uses the PLL O2A, but I've reprogrammed this one to give high band instead of UK40, and we've got plus 10kc for the alpha channels and minus 5kc, and we're going to fit those onto the switches on the front. So very nice. Now I'm going to attempt to give the front a bit of a clean. So we'll give it a good spray with some foam cleaner and the brush, and it does lift a little bit of the grime off, but a lot of the blemishes on the front are actually in the metalwork. Nothing we can do about that, but it definitely looks a little bit better. Yeah, not too bad at all. So because we've got no channel display, we need a way of knowing which is channel 1, and funnily enough, straight up with that dot to the right is channel 1, but I did keep the radio on channel 1 anyway. So we're having a look at the carriers, the 10692 and 10695, and they are a little bit out, but not too far. We'll give them a quick adjustment, get them back into spec, and we'll have a look at the 10240 on TP2, and the 10240 was not too far out, but just giving it a little nudge with the ceramic trimmer gets it as close as we need to be. So just doing a test of the microphone, and everything's nice. So we have audio now, which is better than it was. We're just going to do the LSB offset. So I'm just listening against another radio.
1 2 3 1 2 1 2 3 1 2 1 2.
I'm listening against my Yaesu FT891. So we'll put my audio generator back on the microphone. So we've got 10 watts on AM, 12 watts on SSB with a 2K tone. Lovely. Now we're just going to do a little bit of preventative maintenance. So we're going to change the AVR capacitor, which is always a good one to change. And we're changing this big 2200 microfarad because they like to leak. Not always, but you know, as you can see the difference from what 50 years does in component sizes. So we've just got it on the capacitor tester, and it is low, but it's, you know, it would have still worked, but we'll change it anyway, just for good measure. Just having a look at the 47 mic, it's reading 52, so again, not too far out. And those are the bits we've changed. VCO, final output, 10 ohm, couple of capacitors, a good alignment. You can hear the clarifier being changed on the microphone. So we'll just have a quick scanner on the band, see if we can hear anything. Pop it down onto mid-band. You can hear something on Super Bowl. Somebody from Italy shouting on AM. So there we have it, a vintage radio brought back. Anyway, hope you enjoyed this video. Don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me a coffee, have a look at my website microchips.net. Thanks for watching, and we'll see you in the next video.